Welcome to my pre-algebra class. We're on chapter 6, section 9, which deals with symmetry. A line of symmetry is a line that will divide a figure so that each half will fit exactly on the other. And here's a little short video demonstrating that.
A shape has line symmetry when one half of it is the mirror image of the other half. The fold line, or mirror line, is called the line of symmetry. The line may appear vertically, horizontally, or diagonally. Shapes may have multiple lines of symmetry or no lines of symmetry. Not every figure has line symmetry. Symmetry is found in the world around us, in nature, architecture, and art. Remember, line symmetry is present when the image is mirrored or matches exactly when folded on the dotted line. Can you find the lines of symmetry in these pictures?
There is also rotational symmetry, which is the point of symmetry exists such that the figure can be turned around and will fit on itself. And watch the following demonstration.
This is a quick demonstration on two-dimension rotational symmetry. Now, let's consider this card. When I rotate this card about this point, for 360 degrees, observe how many times this card fits onto itself. Let's start. 1, 2. So, we can see that the card fits onto itself for 2 times. Hence, with this observation, we can say that this card has rotational symmetry of order 2. Alright, let's take another example. Consider this flower. When I rotate this flower about this point, for 360 degrees, observe how many times this flower fits onto itself. Let's start. 1, 2, 3, 4, 5. So, we can see that the card fits onto itself for 5 times. Hence, we can say that this flower has rotational symmetry of order 5. That is all for this lesson. Try out the practice question to further your understanding.
That concludes the explanation of those two types of symmetry. When you do the assignment, ask me for the Myra, which is an instrument that you can use to help find the line of symmetry on a figure in your book. So we're ready for the assignment. You need to turn to page 276, guided practice 1 to 10, exercises 1 to 20, skip 16. So problem number 2, what is the main difference between example 1 and example 2? Well, example 1, if you backtrack to page 275, they're doing lines of symmetry. They're finding those lines where the figure can be divided into two equal parts, one folded on top of the other. And example 2, they're checking lines of symmetry in 1, we'll say that. And they're actually drawing the lines of symmetry. Problem number 4, does each picture item have line symmetry? Explain. Number 4, you don't have to write an explanation, but yes it does, because if you folded that kite in the middle there, one half of it would fit on the other half exactly. Problems 5 through 7, if you ask for the Myras, you can actually put them on the figure and you can see the mirror image of one side fitting on top of the other. So ask me for those as you do these problems. Number 6, you have a rectangle. And it's been turned a little bit like this. And they want to know if this is a line of symmetry. Well, if I actually just went over this line here and this line here and took those two and grouped them, and then I tried turning them, watch what happens. Try flipping the shape. Let's see, just flip it over. I should just flip it. Let's see, flip. Let's go back and undo that flip. It's not going to work. So it doesn't have a line of symmetry. And visually you could see that too. Problem number 8. Trace each figure onto a piece of paper, then draw all the lines of symmetry. If there are no lines of symmetry, write none. So figure number 8 is a square. Well, actually it's a diamond. We'll use the diamond shape. It's a rhombus. Diamond, square. And all the sides are equal and all the angles are equal, so we should be able to get 1 lines of symmetry through the vertices and lines of symmetry through the sides, opposite sides. And problem number 10, it's an oval, so you can trace it. You have it like this, and that does have a line of symmetry right through those two sides and this way. And then the exercises. Problem number 2, is line MN a line of symmetry? Well, they have a picture of an octagon. And they took and drew the line from here to here. And you can see that this half is identical to this half. So that answer is yes. MN is a line of symmetry. Number 4, trace each figure onto a piece of paper, then draw all lines of symmetry. If there are none, write none. So number 4 is a rhombus. Excuse me, not a rhombus, a parallelogram. And they have the lines, if we try drawing a line of symmetry, whoops, undo that. If we try drawing a line of symmetry here, that's not going to fit on itself. You can see that if I duplicate the figure, and then try turning it, it's got rotational symmetry. Let's see if I can do this a different way. Let's just copy. If I tried flipping it, you can see it's not going to work. It should flip right over onto itself. So that doesn't work. So 4, it has none. Number 6 is a hexagon, excuse me, a pentagon. So we'll draw a pentagon. And all the sides are equal, and all the angles are equal. And when that happens, we have lines of symmetry through the, in this case here, through a vertex and a side. So for every vertex and side, we have a line of symmetry. Problem number 8. What type of triangle has exactly one line of symmetry? That would be an isosceles triangle. They have one line of symmetry straight through there. And it's not equilateral. So an isosceles triangle. And number 10, trace each figure onto a sheet of paper. Then complete the figure so that PQ is a line of symmetry. And this is again a place where you could use the Myra to do this. So we're going to trace this figure, and it looks like this. And we want to make PQ a line of symmetry. So we'll just put that right there. So if I take these two sides and group them, and then flip them, well, before let's duplicate it and then flip it, and that's what the figure would look like. Problem number 12 says to look at 11 and come up with a function rule. So number 11 would go here. So we'll go ahead and do 11. If it has it's a regular polygon, it has 3 equal sides, and it'll have 3 lines of symmetry. 4 has 4. We saw that with the square. 5 has 5. And I think you can see the pattern. If it's a regular polygon, all sides equal, all angles equal, the number of sides equals the number of lines of symmetry. So number 12, write a function rule to represent the relationship between the number of sides of a regular polygon and the number of lines of symmetry. Use n to represent the number of sides. So n goes to n. n is paired with n. The number of sides equals the number of lines of symmetry. Problem number 14. These are patterns that you might see in quilts, and they want to know how many lines of symmetry does that template have right now, and how many lines of symmetry can be drawn inside that shape. Well, for every point of the star from one point to the other one directly across it, you can draw a line of symmetry. So there's 1, 2, 3, 4, and then also through where they meet down here, 5, 6, 7, and let's see, do I have them all? No. And actually, you have 8 of them because there were 2 squares inside there. There were 4 lines of symmetry for each square, so it's a total of 8. Problem number 16 you skip, and then we have 17 through 20. And these are to see if the figure that we have here has rotational symmetry. So if we draw the heart and we rotate it, let's duplicate it first. And if we rotate it, it does not have rotational symmetry. But you'd have to do it 360. So it doesn't have rotational symmetry, but it definitely has line symmetry. So 18 is line. Number 20, you have a circle. And a circle has an infinite number of lines of symmetry, because everywhere you go, you can keep drawing lines of symmetry. So definitely lines of symmetry. And as far as rotational symmetry goes, a circle will fit on itself within 1 degree, so rotational symmetry definitely. So the minute I start turning it, it keeps fitting on itself. Fits on itself no matter what I do. So for this, it would be both. And that concludes the evens. Be sure and check the back of the book for the odd answers.